Example 11. How many 5-digit zip codes are possible? All right, so we're all familiar with zip codes. Think about this problem. What first comes to mind? What would you do? Well, is this a permutation or a combination? Well, let's think about, I don't know, famous zip codes. 90210, Beverly Hills, California. Well, if I change the order of the numbers, does that make a different zip code? Well, yeah. Okay, so the order obviously matters. Okay, so that's going to rule out a combination here because, the order, you change the order of the numbers, you get a different zip code. However, there's a problem here. Okay, looking at this particular zip code, what do you notice? Oh, there's repetition. Okay, so if you guys remember, what have I told you time and time again? Okay, with a permutation and with a combination, for both of those things, okay, you can't have any repetition. Okay, so you actually cannot do a permutation and you can't do a combination here. Okay, this is going to be straight up multiplication principle. Okay, also remember we discussed that if you do have a permutation, to solve a permutation, you could apply the multiplication principle, but there are some instances of the multiplication principle that are not permutations, okay? And this is one such example, okay? You have to use the multiplication principle here. It could not be worked as a permutation because digits are allowed to repeat here, okay? All right, so let's go ahead and set this up, okay? So zip codes consist of 5 digits. Okay, so I'm going to fill in the blank here. Okay, the digits that we can use, okay, are our familiar 10 digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we don't have any restrictions here, although I'm sure there are some things that are not allowed, like maybe you can't have all the same number as a zip code, like 11111. Okay, we're not going to factor in those types of restrictions or anything else. Okay, so for each blank, it is possible to have one of these 10 digits in that position. Okay, so for the first number, there's 10 possibilities for the first position. Okay, and then again, repetition is allowed here. Okay, so even if you used a 4 in the first position, you could use a 4 in the second position. Okay, so there's still going to be 10 digits to choose from in the second position, 10 digits to choose from in the third position of the zip code, 10 digits in the fourth position, and 10 digits in the fifth position. Okay, so if we multiply this together, 10 times 10 times 10 times 10 times 10, this will give us 10 to the fifth. Okay, so if we go to the calculator, we will get 10 to the fifth power. Okay, and that's going to give us this number. So we have 1, 2, 3, 4, 5 zeros. Okay, so it's going to look like this: 1, 2, 3, 4, 5. Okay, so there are 100,000 possible zip codes. All right, so I just wanted you to be aware of that. Okay, when you have a test on this material, everything will be mixed up. Okay, sometimes the problem will just be a permutation. Sometimes it will just be a combination. Sometimes it will be straightforward multiplication principle like this. And then in some instances, you'll have a mixture. You'll have the multiplication principle, and it will involve either a permutation or combination. Okay, but just be aware again, okay, that sometimes you will have the multiplication principle not involving either a permutation or a combination.